Hello, guys. It's Mrs.Z. Today we're going to talk about the grade 5, mission 6, lesson 6. It's going to be a word problem. So we are going to use strategy read and draw and write. Okay. So there are two parts of the problem, A and B. So let's see what they want us to do in A. All right, move to, okay. Adam built a toy box for his children wooden blocks. If the inside dimensions of the box are 18 inches by 12 inches by 6 inches, what is the maximum number of 2 inches wooden cubes that will fit in the toy box? So when you think about the Adam built a toy box, but the box is in inches. So 18 inches, 1 inches by 12 by 6. So 18 times 12 times 6 inches to find the volume of that box. But problem is the cubes are not 1 inch cube. The wooden cubes are 2 inches. So there is several ways to solve this problem. So we're gonna start by drawing a picture of that cube or that box. Okay, so Mrs.Z gonna move on here, and I'm gonna try to draw that right here. I'm gonna make a parallel to the edge of the paper. So this is going to be my first, the longest line. Okay, and then I'm gonna make perpendicular lines to make the edge of the box. All right. And then I'm gonna use the side, my rectangular, to make, actually I'm gonna do first the base of the box. So I know this is going to be the face of the box. And then this is on the side. All right. And these are parallel lines, so that those are also going to be the same. So I can do that way. So I can create, and then I can close my lines. So let's see. Okay, hold on. There. Okay, to me, precision is very important. So bear with me, guys. I like to make it the best I can with my tools. All right. So pretend this is that box. So now we're going to go back, and we know that this is the longest side. So this is 18 inches. Okay, and then width is 12 inches. And the height is 6 inches. Okay, so if we calculate the volume of the box, that would be volume 1 is going to be, we're going to use the formula. So the length times width times height. So the volume for the box that is 1 inch calculated is going to be 18 inches times 12 inches times 6 inches. Okay, we can do that, and we can figure it out. What is this volume of this box that Adam made? But now we have another information that the he will put wooden cubes that are 2 inches wide. So if this is 18 inches, we can think about 18 divided into 2. 18 divided into 2, then it would be how many cubes will fit in the length of it. So it would be 18. What times 2 makes 18? That is 9. 2 times 9 is 18. So I know that I could make 9 of these 9 little boxes. So if I want to make 9 spaces, I need 8 lines. So let's see if I do 1, 2, 3, 4, 5, 6, 7, 8. I need 8 lines. 1. Okay, so it would be about 1, 2, 3, 4, 5, 6, 7, 8. Okay, if you want to make 9 spaces, you need 8 dashes about. So this is how would be 9 wooden cubes to fit. So it's the same thing when we think about 12. 12 divided into 2 inches, it would be a 6, because what 6 times 2 makes 12. So then I need here 5 lines in order to make 6 spaces. So let's see, 1, 2, 3, 4, 5. Right. So it's about, so that would be this size: 1, 2, 3, 4, 5, 6 units I made. And then of course a 6, I can make that, and this could be I need 5, so I need 1, 2, 3, 4, 5. About this is just approximately that you can think of. So when you think about here, it could be the cubes. All right. So I can say that. Oops. I needed to divide 6 by 3. Correct. 6 by 2 makes 3. So here I will need only 3 cubes. So I just there made mistakes. So it's okay. I needed 3 lines. So 2 lines only, 3 spaces. All right. 1, 2. All right. So when you think about now, this we can find what volume of the 2 inches cubes would be. So I call it volume 2. So instead of 18, it's going to be a 9 inches, and instead of 12, it's going to be 6 inches, and instead of 6, it's going to be 3 inches. All right. So this volume 2 will exactly tell me how many cubes, tell us how many cubes will fit in this box. All right. So we can also check our answer in a different way. So let's do some calculation now. So the first, if I think about what would be the 18 times 12 times 6, I will use the space above to figure it out that. So I'm going to say, okay, I need to do 18 times 12 times 6. I can do distributive property. So if I'm thinking about just doing 18 times 12, I can do 18 times 10 plus 2. Okay, I will figure it out this first. So I'm going to, then after I get the answer, I'm going to multiply by 6. So the distributive property says that you can distribute one factor 10, 12 into 10 and 2. And so now it's easy. 18 times 10 would be 180. And 18 times 2, you can also think in your head. 2 times 10 is 20, 2 times 8 is 16, and then 8, 20, and 16 makes 36. So when you calculate this all together, 180 and 36, you can think about this to be 20 and 16 if you like. So 180 and 20 will make 200, and then you will have a 16 more. So that is, the answer is 216. But now you need to use and multiply by 6. Again, you can use a distributive property if you wish. So then you can say, okay, 216 is 200 plus 10 plus 6, and you need to multiply that all by 6. So now you have multiple tens, which is 2 times 100 is 200. So you can do 2 times 6 is 12. But what is the 12 hundredths? 12 hundredths. Plus, you can do 1 times 10 times 6 is 60. And then 6 times 6 is 36. And then you can add all these together. So if you think about 60 and 30, that's 90. And then 6, that makes 96. And then you add to 1,200, so it would be 1,296. So we found our answer. We found what is the volume of our big box that Adam created. And then also, when you think about inch times inch times inch, you get square cubic inches. Because if you look like this, if this is inch, and you multiply by this inch, and by height that is inch, then you actually create the cube that is cubic inch. Inch on a power of 3 is cubic inch. So inch times inch times inch creates a cube, and that is cubic inch. So this is equal to 1,296 cubic inches. Cubic inches. Now, when we think about one solution that we are just halfway through, so we know now this is the volume of this prism or box, but inside we need to put the cubes that are 2 by 2-inch wooden cubes. So that is the key, 2-inch. Now we need to find what is the volume of one of those cubes. So I can actually create 2 each cube right here. So I'm going to say this is 2 inches, and then we'll make a square, right? And then make that. So each side of that cube is going to be 2 inches. So the volume is going to be 2 by 2 by 2. So 2 inches is width, to height and the length and the width and the height. So now 2 times 2 times 2 makes 8 cubic inches. So this is the wooden cube, that size of the wooden cube that this child will put in the box. So thinking of that, it should be like, if you look in the picture, it could be how many of these will fit in this. So we know now the whole total is 1296, but we need to divide into volumes of these one cubes. So 1296 divided into 8 cubic inches will give us a total number of the cubes that will fit in here. So let's have some room for division. So we can do that maybe right here. All right. So if I make my 1296 need to be divided into groups of 8, I will use standard algorithm. I'm going to do one number at a time, taking off that my group is 8. So if I have you can think about, if you have 1,000, you cannot share 1,000 into 8 groups. But so that way you can make 0 groups of it. But if you change 1,000 into 1,200s, then you can put 1,200s into 8 groups. Actually, you only can make one group of, so because in 1200s, there is only 8, one group of 800s. 1 times 8 is 8, and then we subtract 12 minus 8 is 4. We can think 8 and what makes 4, or we can regroup as we learn to do so. So 12 minus 8 is 4. Then I will bring, what that means is that you have a 400 left. Now you're bringing down the tens, so you will have now 49 tens. And then you can think, okay, if you have 49 tens, how many groups of 8 you can create. So if you know multiplication, you will know, oh, 8 times 8 is 64, that's too big. 8 times 5 is too small. 8 times 6 would be the perfect, because 6 times 8 is 48. And that will work. We will have 1 tenth left over. But then we will bring down the ones. And now we have 16 ones. And we can think, if we have 16 ones, how many groups of 8 we can make. Of course, 2 times 8 is 16. So we don't have leftovers. So we got our answer. If we have a volume of the cube that is 1296, we can put inside 162 2-inch wooden cubes. That is one way of solving the problem. That would be like if you find what is the volume of the big cube, and then you find what volume of each wooden cube is, and you divide the total volume into sizes of 8. Or as we started at the beginning, now we're going to check our answer by saying, okay, because this was 18 inches, and we say, okay, now 2 inches will be 1 cube. So this is 1 cube, 2, 3, 4, 5, 6, 7, 8, 9 would fit in this. So that would be a 9 of that's and then 12 inches here, 2 inches if you group in the 2 inches, that would be here 1, 2, 3, 4, 5, 6 cubes will fit here. And then the 6 inches tall, that would be there you will have 3 cubes that will fit in a layer. So the we will have 3 layers of 18 by no 9 by 6 by 3. All right, so now thinking of this is 9 inches, and this would be 6 inches, and then your new measure would be here 3 inches. So when I multiply 9 by 6 by 3, I will get the volume 2, which is should get the same answer as if we divide the total volume with the 8. So let's see where did we did correct calculation. So we volume 2, 9 times 6. You can do 9 times 6 or 6 times 3, whatever you feel comfortable with. So if you do 9 times 6 is 54. That would then you have to multiply inch by inch, which makes squared inch. Multiplying inch by inch, you get squared inch. And then you will need multiply by 3 inches after that, which will give you now square inch times inch will give you cubic inch. And then we can use distributive property as well. We can do on the side, or we can do standard algorithm if you're comfortable with that. 54 times 3. So 3 ones times 4. 3 times 4 is 12. I remember 1. I circle and highlight so I don't forget what it is. Okay, I'm done with 3 times 4. Now I'm doing 3 times 5. 3 times 5 is 15. I put 15 on the top because that'll help me to add 1 to it. So 15 plus 1 is 16. And we got what volume 2 is. And the volume 2 is 162 cubic inches. So when we look this, we know that if we have the same answer, 162 and 162. So we figured it out that there will be 162 2-inch wooden cubes. So we did read, we draw, and we write, and now it's time to write. So usually when I am ELL student, I didn't I wasn't born here, so I use whatever strategy could to help myself to correctly write. So in a question, I find a vocabulary that I can use if I need to type the answer. So my question was, it says, what is the maximum number of 2-inch wooden cubes that will fit in the toy box? If I want to answer a complete sentence, I could use like this language. I could use the maximum number of 2-inch wooden cubes will be 162, or I can say 162 cubic 2-inch wooden cubes will fit in the toy box. In will fit in the toy box. So all those orange, I can use that to help me rewrite my statement. So, okay, the maximum number, maximum number of 2-inch wooden cubes. The maximum number of 2-inch wooden cubes is 162 that will fit in the toy box. The maximum number of 2-inch wooden cubes is 162 that will fit in the toy box. Okay, so if I try, I kind of made the little bit, so that would be the answer. So if I try to reconstruct this, I could. It's gonna be not perfect because they won't be the cubes. I made mistake. I made it like this. The much bigger. So, but still, you can think about being filled these into the boxes. Thinking about that. All right, so, and then this would be, this is not exact, but it's just explaining to you what we were working on. We were filling in the box with the cubes, right? And it should look, when it's box full, it should look like this. Like, but not exactly, because I did not do well drawing. Right. So, about something like that. And I needed to make it smaller so you can see, right? Okay. So, that is the first part. Now we have the second part, which is what is the Adam? Okay. What if Adam had built the box 16 inches by 9 inches by 9 inches? What is the maximum number of 2-inch wooden cubes that would fit in this size box? Okay, so that we can try to see first if we decompose these factors into prime numbers, we can see if the first one was like, let's see, volume 1 was 18 by 12 by 6, and then the volume 2 is in a B, is 16 by 9 by 9. That's what they say. What if Adam had built the box 16 inches by 9 inches by 9 inches? What is the maximum number of 2-inch wooden cubes that would fit in this size of box? So the first if we look the volume, the numbers are different, but if we do the prime factorization of 18, that would be like we could do 2 times um, 2, if we do 3 times 3, that's 9, and 9 times 2, that would be the 18. So we can make this 3 times 3, that's 9 times 3 times 2 is 18. All right, so 18 is build of primes, 3 times 3 times 2. Let's do the 12. 12 is, you can do 3 times 2 and then times 2 again. So 3 times 2 is 6, 6 times 2 is 12, and then 3 is 2 times 3. Now let's see the prime factors of uh, the second box. So if we do 16, that would be, if I say 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So it would be you would have 4 twos. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And then 9 is 3 times 3, and another 9 is 3 times 3. Now we're going to compare factors or primes factors. Prime factors, I can see that in this volume I have 1, 3, prime 3, prime 2 threes, 3 threes, 4 3 prime factors. And if I look on this one, is also 3, 1, 2, 3, 4 threes. So 4 threes on this side and 4 threes on that side. Okay. Now, if I look twos, here is the 1, 2, 2 twos, 3 twos, 4 twos. And here is 1, 2, 3, 4. Okay, so they have the same amount of prime factors, 4 threes and 4 twos, which tells me that I don't even need to calculate. I know that this are gonna be the same volumes. This is volume 1, is, we already know it's calculated in 1296 cubic inches. So 1296 cubic inches. But I can tell you that this is also volume 2 is the 1296 cubic inches. What is different is the size of this box is shorter than this one, and then this box is wider than this one. So that the dimension are different numbers, but the volume would be the same. So the question is, how many of the 2-inch wooden cubes would fit in? If you think is the same, we have to prove it. The volume of each box is the same, but can in each box fit the same amount of 2-inch wooden cubes that are size like this? That we can prove. Here we had a perfect perfect dimension because 18 was divisible by 2, and we were able to fit 2 inch divide into 2 inch 18. Here is also 12 was divisible by 2 inches, so we were able to fit 6 cubes in this side, in the side. And then the layers were 6 was divisible by 2, so then when we think about new picture of the different uh, box that Adam built, we can see that this was 16. Okay, let's do the 16. Okay, by I'll do 9 this way. All right. Okay. By 9 and by 9 as well. All right. So this was a 16 inches by 9 inches and by 9 inches. So when you think about 9, you can divide 16 divided into 2 will give you 2 times 8 is 16. So here I can divide that into 8 parts, and we'll have the each cube can fit in. But if you try to think 9, it's not divisible by 2, so you can do 4 cubes, but 1 inch will be extra, and the same thing will happen in that height, because if you take 2, 4, 6, 8, you will have 4 layers of 2 inch size cubes, and 1 inch will be extra. So in by this now you can think in this box uh, it cannot fit 162 2 inch cubes. It should fit less than that. So let's talk about that. So now if I create that cube and that box, I'm gonna try. All right, so here you go. Let's be all right. Sorry, I'm using it. Can you see it? Yes. All right. So about okay there. Okay. Mm. Turn this. So now, when you think, imagine that this is 8 inches. So you're gonna do like you will have left over. You will have 2 inch. So it would be 2 inches, 4 inches, 6, and 8, and 1 inch will be extra. So here is the one wooden cube, 2, 3, 4. So this would be 4 cubes that or 4 cubes, not 4 inches, but it would be that different. So now this is going to be 8. So I'm going to create. Let's do that. Okay, so 1, 2, 3, 4. Okay, again 4. So here it will be perfect. 1 cube, 2 wooden cube, 3, 4, 5, 6, 7, 8 can fit this way. Okay. And then height is also 9 inches. Okay, so if you think about 2-inch cubes, you can have extra inch, and then you will have 4 here. Okay, so it would be like this. So it would be one, two, 3, 4 layers, and then the top would be the extra. So in the bottom would be fit, um, and then this top would be empty. This top would be empty, and then the side also going to be empty. So you will be able to um, to to put cubes, 2-inch cubes, in this area here, volume, and then on the side there will be this space empty, and then on the top this 16 by 1 inch will be extra, and then 1 by 9 will be the extra, so that would be extra space. We could fit, if we can cut the each, if there is a half a size of the blocks like this, then we could probably fit in there some more, but let's see how many cubes can really fit in right here. Right now, you can see that instead of, it would be, so your dimension will be 8 by 4 by 4. So the volume of box, let's see, okay. Not the volume, I would say, like how many uh, 2-inch cubes would be if I multiply 8 by 4 by 4. All right, so this, okay, so if you do 8 times 4, 32, and then times 4, you can think about 32 times 4. 2 times 4 is 8. 3 times 4 is 12. So the 128 2-inch cubes would be fit in this part. So that is less than 162. So in this box fit 162 2-inch cubes, and in this box fit 128 2-inch cubes. Okay, so when dimensions are not perfectly aligned with the size of the wooden cubes, it could happen that we have extra space that would give us a problem to fit if he has 162 cubes. So in that box cannot fit that all. It's only 128 cubes. So you can also prove your answer if you go and say like, okay, this is it's already too long lesson, so I don't want to bother you with that. I'm just gonna go with answering in the word. So what is the maximum number of 2-inch wooden cube that would fit in the size box, in this size box? Where are the answer is, but if we want them, we can write in this size box. Atom can fit only 128 2-inch wooden cubes. And that was it. This was Mrs. Z's answer for lesson 6, grade 5 word problem. Okay, so I hope this made sense to you guys. It's kind of pretty long, so I hope that will work. Okay. Thank you for listening. Goodbye.